Good afternoon. Well, hello everybody for the global everyone watching us. My name is Brunel. I'm the session chair for this session, and we're about to listen to Christopher Jones sharing his ideas on efficient data handling techniques in Python 4, I suppose. All right, and Christopher, it's over to you. Let me keep
Thank
going.
you. Good. So I think we're live. Welcome, everyone. Really great to be back presenting. Great a lot of activity there on Discord. I could see that's really fantastic. And I really just want to thank the organizers for putting all their spare time into this. I know with open source communities, there's a lot going on behind the scenes. My name is Christopher Jones. I work at Oracle in the data access group. Just letting you warm up to my voice because I kind of grew up in England, went to school in Australia and America, and had 10 years recently in California at Oracle's headquarters and just back in Australia. So it's quite late here at night, so the lights are a little bit dim. But apologies if you don't get my vowel shifts and they're a little different to the ones you're used to. We all do speak the same language. So just to warm up, my wider group looks after a lot of data access APIs into the Oracle database. And I look after mostly what we call the C stack. Obviously today we're going to be speaking about Python language itself. We value all of our community members out there. I worked for a long time purely on PHP, doing a lot of upstream PHP work and PHP stuff for Oracle, and now I have a sort of broader portfolio. So as a product manager, I kind of look after the community liaison, reviewing specifications, speaking to customers, coming to conferences. I'm doing a lot of project management as well at the moment, just getting all our driver schedules aligned and all the features aligned as well. So just to give you a slide, I think this is about the only slide I have, and then I'm going to go straight into code. I'm going to be talking about our CX Oracle interface. It's the Python database API compliant module for Oracle database. It has little asterisks there because there are a couple of things which aren't supported. Some of the smaller things like fetching result sets. But we have a lot of extra functionality on top because Oracle has a lot of extra functionality in terms of high availability and features for queuing and continuous query notification and all sorts of fantastic things like that. Unfortunately, in a short session today, we're not going to get into some of those details, and I tried to focus the talk a little bit on where I'm seeing questions come in from users, Stack Overflow and forums and GitHub issues and all over the place. So CX Oracle module is available from PyPy. So there are precompiled binaries there. There's also source code if you want to compile it for other uses. It is what we call a thick client driver. So it sits on top of some proprietary libraries, the Oracle Call Interface C stack, which you have to download separately. So apologies for that. That's just the way it is at the moment. Pretty easy to plug them together. I'll show you that a little bit later. Obviously, you're talking across the database, and the database could be on the same machine as Python, remote database, could be in the cloud, everything could be in the cloud, it's all whatever you like, it's just talking across the network. And you're all Python people, so I don't need to talk a little bit more about that. It is often hard on these talks to know what skill levels people have coming in, but I assume you don't know a lot about Oracle database, but you know a little bit about databases. So today, as per the abstract, really want to talk about connecting such a major part in databases. Want connections to be reliable, available, fail over correctly if something goes wrong. Fetching, as promised, want to make sure that's really efficient. Loading data. Do see a lot of questions about CSV, so I put CSV into the abstract. Obviously, data loads can come from anywhere, but the techniques will carry you through. And I'm actually going to have time today, I think, to talk about a little bit about some of our JSON storage technology in the database as well. So let's go across to the demo. So just running here in Jupyter, as you can see, so apologies, there's obviously going to be a lot of stuff on the screen, but if you can just sort of bear with me as we run through standard Jupyter bits and pieces. As you can see at the top, kind of cover those sort of 5 sections depending on time. So installation, standard pip install, obviously -- user if you're don't have privileged access, and for us corporate kinds of people, proxy is always useful to access to get out through the firewall. So it's not difficult to install CX Oracle. Then, as I mentioned with that architecture overview, you need some kinds of Oracle client stack libraries. The easiest way is this Oracle Instant Client, which is pretty much a zip package or an RPM package if you're on Linux. you can automate download of that. It's available on Oracle standard platforms, Mac, Windows, Linux, HPs, AIXs, all those sorts of fancy, wonderful things people use. It comes in a number of packages, SDK with header files, some tools packages, bits and pieces like that. We just need what we call the basic package, which is the shared libraries. So wget, unzip, Mac OS people have a DMG package. The install is slightly different, but there's a README in the package which shows you how to mount that. You can also script that as well if you want to script the install. Linux, we have yum.oracle.com, a Yum server. So on Oracle Linux 7, Oracle Linux 8, anything else which uses RPM packages, you can download Python as a package, the CX Oracle driver API as a package. Never know whether to call it an API or a driver or an interface or module or whatever, but it's the bit which talks to the database, and those client library RPMs. So you can have everything managed through RPMs on Yum in the OL7 era or DNF in the OL8 era. This package manager has changed a little bit. So you've got those two things installed. What do you need to do? Hook them together. The easiest way actually is to use this new function we have, init Oracle client lib. Works on Mac OS and Windows, and you just pass in the directory of those libraries that you've downloaded. Sadly, on Linux, you have to actually do the external configuration before the Python process starts. Not too difficult. ldconfig is the fantastic way to make sure everything is portable across the machine. Otherwise, you can use a standard LD library path, and these need to be set before Python process starts. Windows, you can do the same with a path environment variable, so you don't need this as well. And Mac actually has one extra little way. You can add a symbolic link under where the shared library for the driver is. If you can navigate down under your Python install packages, Python package install, add a shared link into this directory, and everything will work nicely as well. So there are a few ways to do that. There's a lot in the documentation of all of the variants that you can follow through. So just rolling through, connecting is obviously key, as I mentioned. You need some credentials, obviously, to connect to the database. I've set some up here. You don't need to hardcode the password if you don't want. You can obviously use environment variables, or we have all sorts of kinds of external authentication, remote authentication services, identity managers, and things like that. You can use effectively what we call external authentication, so you don't need to have password exposed. Demos, obviously, passwords are great. How do you connect? How do you tell your Python application where the database is? Easiest way is what we call this easy connect syntax. As you can see, host name of where the database is running, and the service name, which is just the name that the database advertises itself as to connect to. And obviously, when I run my little bit of code, yes, you can see that it connected, and that's who I connected through as. Named parameters, one little quirk from the DB API is that this order is not actually compliant with the API specification, so it's probably better just to use name parameters and stick with any order. So if we ever do decide to change the order for whatever reason, then you're covered. We're up to Oracle 21C. That's come out recently in the last weeks, really. But in the version before, last year's version, then we had an improved syntax which had this URL syntax. So you can see the question mark and the ampersand. Maybe I should just bump that up a little bit bigger for the screens. And you can see connect timeout. So if a connection can't be established within 4 seconds, return an error back to the application, so you get a better quality of service. Expire time actually is an odd name, but it's really just setting the keep alive. So it's doing a ping across from your Python application to the database every, in this case, 10 minutes. So if the database has gone down, network's gone down, you can get an error back faster, or more importantly, if the firewall is going to time out something which is idle, then this is going to send that keep alive across the network, and the firewall won't time out a connection which you probably created because you want to use it at some stage, so you don't want the firewall killing it. So there's a whole bunch of options in here you can add for all sorts of high availability features as well. But what this really means is you don't need all of the kind of configuration files that Oracle people might be talking about, and I'll cover some of those a little bit later. Connection type, so we saw that just before. Standalone connection, creates some kind of memory in the Python process, database pipe gets created, some server process gets started, there's something called session memory, et cetera, nothing magic there. When you finish with it, you close the connection and all this stuff gets torn down. Most of you probably actually do want a pulled connection. So pool connection is useful when you have large numbers of application users, large numbers of requests coming in, need to be serviced. They're not long lasting, so they hold on a connection, do some work, and then finish their work and release this back to the pool for somebody else to use. Pools are obviously growable, so they can grow and shrink, so resources can be managed better. And more importantly, these are created during application initialization. So you would create this pool inside your Python process once at app startup. These are pre-warmed up, as it were, established, memories allocated. And then when your application users start coming in to use the application, these are just ready to go. So it's really quick. You don't have that time delay to establish multiple packets backwards and forwards to negotiate the authentication. So the session pool is also, sorry, and I call it session pool, connection pool, they're interchangeable in this space. This pool is very useful because it actually supports some of Oracle's high availability functionality, which the standard connections don't by default. So you might have heard in the Oracle land things like fast application notifications, so getting errors back faster. Quite often you see a cluster of databases, so maybe 2 or more databases, and you can connect through to those databases. They're talking to the same data files, so they're just instances of the same data set. And so FAN would send notifications if one of these was going down, so the pool will nicely clean up and not give you connections to that database which is going down for planned maintenance. Some of our other buzzwords I'll just mention: application continuity, database resident connection pooling, things which actually I'm not going to get time to cover today. They're all covered, handled by the session pool technology. So session pool actually has some benefits, even if you are perhaps even just opening one connection to the database and holding on to it for a long time. You'll get messages back faster from the database. So session pool, as you can see the word here, just to create it, obviously you have parameters for growth characteristics of the pool. Min 1, so it's going to start with 1 when it's created. Obviously you're only allowed to grow up to 20, handle 20 database workloads at a time. You can obviously have many more application users as long as they're not trying to connect to the database. And then you want to acquire the connection, and with the with block, obviously you're releasing the connection at the end, so connection goes back to the pool. And if you weren't using with block, you do a connection.close, which would give that connection back to the pool for the next user in the application who wanted to use it. And this will probably do nothing except say get our connection. Yep, good. So the professional tip, the pro tip, is use a fixed pool size. I should have put this in double bold font. Our real world performance tuning team, the fantastic team which go out to a lot of our customers and deal with the hard complex problems, they often see problems with people actually doing what I've got up here, where there's a growth of the pool. And that is because in the morning, 9 o'clock rush, as we used to have when we all used to go to offices, everybody would come in, the pool would be trying to grow. So all of these blobs at the top would be trying to be allocated, some memory allocation would be happening, and there'd be interrupts and all sorts of things. And then the users who were connected would actually be trying to do queries, and things would not be as stable as they could be. So their professional tip is that you have a fixed pool size where the min and max are the same. Increment can be 0, or in newer versions, you can actually bump that up a little bit. So in case there's a big outage in the pool, then it will grow up back to its stable size a bit faster. So when you are using a pool, one common thing that people do immediately when they connect is try and set some session state. We want to set the date formats which are being used. We want to set the messages, languages which are going to come back. And you can do that. You just, in Oracle land, execute this alter session, and that's great. But it is extra work on the database every time you do get connection. So you don't need to do that, as you've probably read ahead. This is a callback when you create the pool, and it's only going to get called once per, in this case, once per each of these 4 connections in the pool. So those connections will stay in the pool. This session state stays with those connections. Now, the session state is different from a transaction state. If you're doing an insert or update, the transaction state, when you cause a connection, push it back to the pool, that will be rolled back, or obviously if you commit it, it'll stay committed, but it'll be rolled back and cleared. The session state, however, does stay with that connection. And that's really useful for performance, because it means you don't have to keep executing these all the time. Obviously, again, you do the pool acquire, and this is guaranteed that whenever this returns, these alter sessions will have run. So this callback gets called before the acquire returns the connection back to your application for use. Here's a little bit example. So without that callback and with the callback, So without the callback, pretends I had 1,000 user requests come in, so I have 1,000 get connection calls. Max is 4, as you can see. Without it, I have to do these all the commands, 1,000 of them, and maybe I'm doing just 1,000 selects. I'm get a connection, do a query, finish. So overall, that's 2,000, 1,000 plus 1,000, 2,000 calls into the database. But with a pool, because that alter only has to be run once per connection in the pool rather than once per request, I'm halving the load, effectively halving the load on the database. So this callback is certainly something to make use of when you're using a connection pool. So time is running quickly. Let's just run on. So I wanted to talk a little bit about Autonomous Database Cloud. So you hear these words autonomous, you wonder what it is. You can hear data warehouse and ADBS shared and dedicated and all these other buzzwords within Oracle. It's all the same database, just configured slightly differently for different workloads. And it's the same database as you could have and install yourself. We have free versions of the database, something called XE, Express Edition. The latest 21.3 on Linux came out, and Windows is due out soon. So you can install that and use it. And in fact, you can install our bigger Enterprise Edition as well, if you like, which doesn't have some of the space and processor limitations. But the XE Edition functionality is going to be the same as you get in this cloud database. But the cloud database has an always free service, which I kind of do recommend because it's just great for hacking around on. And it is free. It may ask you for a credit card when you sign up. And when you do initially sign up, you kind of get access to everything. And then after a while, you'll lose some access to the sort of higher end functionality and just be left with access to creating compute instances and databases and whatever else they've decided at that stage you'll add access to. But this autonomous transaction processing, as I mentioned, data warehousing and transaction processing, same database, but this is a standard one which you would just create. It's just a few button clicks. I'm not going to go through it. It really is quite simple, and as I say, always free. So once even that free trial has come out, you'll still have access to this database. We have at the moment a wallet situation. We have to download a certificate from the database, and one thing I've kind of glossed over is a little bit, when you actually do create the database, I think it's default, you want to allow secure access from everywhere. If you can just read that on the screen, there's a checkbox earlier when you create the database, which means then you can, on your laptop, connect through to the cloud. But we need to get this certificate down, and at the moment, we have to click through, download the wallet, and this gives us mutual TLS, so it gives us that higher security. Now, the fact that this is a drop-down, as you can see, means that something's going to change here. And in fact, I know for the Java world, they already allowed one-way TLS, so they actually don't need to do what I'm doing here, which is downloading this extra certificate. That's coming soon to Python, but it's not quite there yet. But it's pretty simple once you've downloaded that. It's a zip file. There are 3 files in there that we need. There's a bunch of other files that Java people like, the Java weenies like, but the Python people just need these 3 files. And if you're not familiar with Oracle, this has some kinds of network aliases, just mapping databases to where the host and IP, as we kind of saw before, that service name, host name and service name, just aliases that. SQL.io has some configuration options, so you can set encryptions and security, and even if you want to dump stack traces and things for debugging, this is all that kind of configuration file. And then the C wallet is the certificate. You still need a password with Oracle Cloud databases, even though you've downloaded this wallet thing. Some Oracle wallets actually do have usernames and passwords in them. This one doesn't. And you can either use that alias in the connection file, or you can use exactly what I've done earlier when I showed you the Easy Connect syntax. I kind of peeked in the TNS name Zara file. I pulled out, as you saw, the host name, the port name, with the listening, and then the service name. And then the other thing I need to stick here is the wallet location. And this directory on my disk has this certificate file. So that's all I need here. I don't need any other configuration files, just need that wallet file. And theoretically, when that runs, yes, it's connected through the database, executed a simple SQL in the Oracle land, and printed my username CJ out. This syntax, by the way, also for those people behind firewalls, and I do mention that because often we are in the corporate world, you can actually append onto here proxy, so you can go through an HTTP proxy if you want, which is useful for development, obviously a bit slow for production, but kind of nice. So that's really the connectivity bits. Install CX Oracle, install an instant client, connect the two together, and away you go with connections. Use a session pool in most cases, connection pool. So running on quickly, because I've spent a little bit of time on that, queries in Oracle land, we tend to really say query, and we mean select and with statements, not just any SQL statement. Let me just run through those things to set up the passwords, etc. And the key takeaway here that we have throughout all of Oracle design is reducing the round trips. So those round trips come from the Oracle client libraries to the database and back again, and that impacts scalability. The database has to wake up, there are interrupts, has to do processing, has to send messages back. So we really want to reduce the number, and we'll see that again and again. CX Oracle has the standard DB API stuff, fetch one, fetch all, fetch many, which you can use in any order that you like. Obviously, you're going to get all the rows back from the database. If you loop over fetch one multiple times, you get the same number of rows back if you had the same query. Fetch many, obviously useful for batches, and the key thing here is that there's a tuning parameter in terms of the batch size, which comes back. And this also can greatly improve performance, as we'll see in a minute. So this is a key thing. So we have two tuning parameters which are buried here on lines 21 and 22 for fetching data. So these don't affect the execution of the SQL. That's all handled by the database optimizer. You can add hints, you can add indexes in the database, you can do a bunch of stuff on the database side. That's kind of out of control of the Python user. For the app side, the key thing is getting that data back across the network. And these two parameters are tuning parameters. They don't affect how the data is returned to the app or when. They're internal buffer sizes. And there are two of them because there are different layers of Oracle libraries, and we separate our execute from our fetches, and they're different bufferings. But the bottom line is you should go and tune these in your production environment where you are testing your actual network latency as we are testing your full data sizes. It's okay to get some rough tuning in development, but it's only in the production that you'll actually see how these play out. So you can see here I'm getting in Oracle land, getting my session ID, because later on I want to count those round trips backwards and forwards to the database, and I do this as a privileged user, but I need to know which unprivileged user I'm collecting these for. And as you probably read ahead, I'm getting that round trip count and then getting it after I've done my workload and doing the subtractions. I'm getting the difference. So at the end, when I'm printing out the number of round trips backwards and forwards to the database to fetch all of these rows, just fetching a number of rows. Let me run that. You can see the calls to my workload and then the output. And the top here is with the default values. Prefetch rows 2, array size 100. And you can see if I'm just fetching one row, it only takes one round trip. Message across the database to do the select, also returns data back, and I get all the data back. As the number of rows increases, the number of round trips increases. And so you might want to be tuning these two values. And the first thing to look at tuning is if you're getting a page of rows, do a standard web page, in this case 20 rows. What values do you set? As you can see, if you add one to prefetch rows, or make prefetch rows one bigger than the number of rows, then you reduce the round trips back down to 1. And there's internal reasons about checking for end of fetch. If the buffer size is full with 20, you don't know whether there's one extra out there, so you check by extending the buffer size by 1. Just the kind of way the implementation went when they did this. So we live with it, but it's not difficult. Obviously, as data size gets bigger, then you want to start really bumping up these values, round trips, etc. You may find that you just want to leave prefetch rows at 2 and just bump up array size. That's pretty common and standard. And certainly for big data sizes, there's an extra memory buffer copy when you start using these prefetch buffers. So you may not want that for very big amounts of data. I've got some timings later for showing round trips, and we'll have a good look at that and see how these really do affect time. So that is the most efficient way to get data out, regardless of which one of the fetch one, fetch many, fetch all things you're using. Set prefetch rows and array size. There are some things I'm not going to cover in terms of tuning network. You can look at the CX Oracle manual for some of those things in the tuning section. So DML, data manipulation language, insert, update, delete, merge statements. Again, let's just run through my standard stuff. So I'm creating a little bit of a dummy table. And in Oracle land, it's always worth talking about binding. So we see a lot of people doing string concatenation, so they have their data concatenated into their insert statement. So the SQL and data just goes across as one string to the database. That opens you up to SQL injection attacks. It means the database sees probably a different SQL statement each time because the data values are going to change. So it parses it, it sees it's different, it has to recalculate its optimizer and security access and all that sort of stuff. So bind variables are the way to get performance and security. And there are various syntaxes, as you probably know from various drivers. Oracle uses the bind variable syntax with a colon. So it uses a number or a name here. And this is what we call bind by position, because these data values in the execute call are just being mapped straight across in positional order. That's kind of okay until you start having large numbers of values, or somebody repeats one of these bind variables, or somebody deletes one in a SQL statement. So it's probably better just to use a dictionary. And you can see the names here of the keys match the bind variable names. Alternatively, you can use keyword arguments, but I don't see that too common except for very small values. So this data gets sent across to the database separately from the SQL statement, so there's no possible SQL injection at this point. And as I mentioned, this whole context, what we call it, the cursor, the stored shared area in the database, can be reused. So very, very important in terms of performance and scalability. Now, execute's great, but if you want to insert lots of data, in this case, 7 rows of data, 7 records, you don't want to be looping around execute 7 times. Just call execute many part of the DB API once. Again, we're using bind names here. We're just using the sort of numbers. So we don't have any names. And as you'd expect, I'm going to insert 7, and I'm going to query the results back and the rollback at the bottom, so I can just rerun that whenever I want. So this is very efficient, and we can show that by a little bit of magic, which I'll sort of kind of skip the framework, but we're going to insert data in a loop. So this is going to call execute number of times, versus lower down, we're going to call execute many with all of our rows in one hit. And then at the bottom, we're going to plot that. So we'll just run that because that takes a little bit of time. And we should start seeing some results when it's decided it wants to wake up, which it will in a minute, I'm sure, because my demos always work. Oh, there we go. Good few. Don't know what they are, because it certainly was a bit longer than that amount of time. But you can see pretty obviously, even if you look at 1,000 rows, so you're inserting 1,000 rows in a loop, 1,000 execute calls, 2 seconds versus just doing that one call in 0.1 second. So we saved a large number of round trips, and this is where the time for round trips has come in. And the blue, obviously, the execute loop just goes up like, I dare say, a covered graph. So let's keep everything flat. Let's make this a flat, lower the curve. Let's use execute many. So that's a key tip for inserts, even for small numbers of rows. You can start seeing some benefit. Your mileage may vary a little bit depending how many columns you have, how close your database is, how fast that network latency is. You need to benchmark this, but almost every case you want to be using execute many if you're inserting more than one row. And when you are doing this, you're often inserting a huge number of rows. So that data is often noisy, so you kind of get some errors. And we have a convenient way to handle that. So at the moment, I've just got a couple of dummy tables, parent and child. And you can see this foreign key, 50, 50. So there's a child of A. Got some data here, which is noisy. So it's got duplicate key. So that's not going to be allowed. That's going to be an error. It's parent 75 doesn't exist. I've only got up to 50. So this is going to cause some problems with data. And I ran it, and yes, errors at offset 2 and offset 4, which is 0, 1, 2, 3, 4. So these two are the erroring rows. And more, oops, sorry, I ran it a second time. That's annoying. Let me just go back and roll back and do that again, so it's kind of clear for you. Okay, so I've got the 2 errors again, and then if I do the query, you can see that what actually happened was the 3 valid rows did get inserted. So that's great. Maybe only 0.01% of our data was noisy, but the rest actually got inserted, which is fantastic. Now, at this point, you get the choice. You can go back and work out what you want to do with these invalid data, this invalid data. Do you want to fix it and then reinsert it? Do you just want to ignore it? And you get to commit or roll back. So Oracle has something called auto commit mode, and that's a very efficient way of not having to do an extra round trip to do an explicit commit. But even if you've got that turned on with this case when you're using the batch errors mode, then it's going to be ignored. And that is so that you get that chance to work out what you want to do with this bad data. So you then have to explicitly commit or roll back. And as you saw me run ahead before I kind of rolled back, so my demos work repeatedly. So let's just run in. We've kind of running out of time. CSVs, you all know CSV is not well-defined standard. I do have some kind of jokes which you should seriously think about. Don't use CSV files. Just keep everything in the database. Let all your tools access it. There's no issues with number conversions. There's no issues with Excel spreadsheets reaching their limit. As we've seen recently, we've got Oracle tools like this thing called Apex, which let you build applications really quickly. You can use Python. But most of us do want to use CSV files. We have another tool called Data Pump, which is just a data loader. That's a very efficient way to load CSV files, very flexible into the database. But for the Python program, obviously the helpful solution is the CSV module. So it's highly available. Let's just set up my connection and stuff like that. So reading the files, I've got a little bit of a dummy table there. And our CSV data, as you can expect on my disk, is just a couple of rows. And we've seen this before. We've seen execute many. The key difference here is that we are inserting in batches. So we're looping and calling execute many, because you probably can't insert in a million rows at a time across the network. So you're going to have to insert in batches, and you're going to need to choose your batch size. Obviously, batches may not be exact multiples of in this case, 10,000 rows. And so at the very end, you may have a little bit data left over. You might have to do a one final execute at the bottom. But we're using the CSV reader. It's comma separated, so set up the delimiter. Insert statement with the bind variables, as we saw earlier for execute many. CSV reader gives us our data. So this is each of these elements of the array are now corresponding to each of the columns. And we can insert and get the data back. So by very efficiently using execute many, choosing an efficient batch size, you can load data. One thing I've kind of skipped over is this set input sizes. So CX Oracle is going to be allocating memory, and for the way it works, it has to have a fixed buffer, a slice, as it were. And so if you start with a small amount of data, it's going to allocate a certain amount of space in that buffer, and it's going to think each row will fit in there. And when it sees a slightly larger value, it might have to reallocate all the previous data. So the set input sizes is a way to avoid that reallocation cost. None, obviously, we've got a number, we don't care, the size is kind of fixed, you can't change that. And then 30 matches, in this case, the data size of the table. And you can have as many parameters here as you like, matching the columns for this cursor that we're going to use. Writing CSV files in the last couple of minutes before I just run quickly into the soda. Same sort of thing, and we've seen this array size. I mentioned you may not want to fiddle with the prefetch size, so in this case I didn't. In this case I got some timing, so we can do a little bit of timing. And you can see, 10,000 rows in half a second or so. And yeah, just a quick check that yes, I got all of those inserted. And depending on how fast my database is now, much slower if I have a slower array size. So that was the round trips that we saw earlier when we were doing inserts. When we're doing queries. So obviously you probably know CSV module. If not, it has a bunch of options. I'm in the Mac Linux world, so I like the \n line terminators instead of the standard character return line feed. This iterates nicely across the data set and just makes it sweet. So, but the key thing is using the Oracle technology nicely to do that internal buffer tuning. So let me just finish up quickly with Soda, which wasn't officially in the abstract, but I think is very useful. So Soda is a document style API. By default, it deals with JSON, so most people just think of it as dealing with JSON, but it doesn't actually have to necessarily have to work with JSON. Out of the box, when you create a document, it'll store JSON documents. Queried, retrieved, access, no SQL style. It's actually all backed by Oracle's SQL technology, so you can actually, if you really want, dig into it from the back end in SQL. But that does mean, because it's in our standard tried and trusted technology, that's all backed up, roll back, roll forward, anything that you like with it is solid. So I'm just setting up here my standard connections. I mentioned auto commit before in terms of execute many. Simple SOTA usage, you might want to just turn this on. It just reduces round trips. The expectation is you're just doing a quick thing, just inserting a document. You're just dealing with a single document at a time. If you're not, I would turn this off. We do, by the way, have the equivalent of the execute many to insert multiple rows. So you don't have to worry about that slow issue of having to do repeated document inserts. Get SOTA database, as I just kind of skipped over, really just as a placeholder. And then you have a collection of documents. Sorry, I was using document before, but I meant collection. And that kind of corresponds, if you're still thinking in relational tables, if you're not in the JSON world yet, that corresponds effectively to a table. Now, documents can have metadata describing them. They can have auto-incremented keys and all sorts of things. We can change how the storage happens in the back end of the database. A lot of improvements going on, and the default has changed between versions. So just for consistency across here, I just explicitly state it using the old school, which is probably a little bit slower than if you're using the newer, later stuff. But at least this works everywhere that I run it. So we create collection, or we'll open if it already exists, and you insert key. So this is obviously just standard Python syntax, and we have an insert one. I mentioned we had an insert many before, but we're just going to insert one document, and we'll get the key back. So this metadata comes back as part of that insert, and this was the auto-generated key, which I could have changed with my metadata up on the top of the screen if I'd wanted a sequence or something like that. If I'm using GraphQL, the sequence numbers are kind of good because GraphQL tends to work nicely with those. And as you can see, I've got a whole bunch of operators. This is a chained kind of syntax, a find syntax, passing in the key I just got, getting one document, then getting the content of that document. No real magic. And you can get back objects or JSON strings as you like. Replacing, as you'd expect, as I just rushed through, so we have got a little bit of time for questions. Works well, just replace one document, passing in the same key and the new content. And we can just call, just for argument's sake, insert a whole bunch more. And then we have a whole bunch of the filtering. So we have here $like, which is Oracle's sort of pattern matching, or you can do regular expressions, et cetera, et cetera. And as you can see, I was matching anything which began with MA. Counts, so if you want to do a count of how many documents you have, if you want to do filters, here's the regular expression. So I've removed a bunch of documents. Everything's in the control of you as a user here. So that seems very brief. I've kind of just shown you stuff without perhaps talking about how great it is and how wonderful it is. I didn't really want to go into the marketing speak a little bit. Did want to show you Oracle Cloud, just so that you saw that, so that you're aware that it's out there and just a handy thing to have around. If you're trying to write an application which needs to talk to multiple databases, you can just set up that free cloud account and just start and stop your database and get your applications working against that without any issues of having to install things locally. With large number of data centers out there that it's available in. And that is it from me. I have a bunch of slides there, which were just in case my demos failed. Let me just go back to the top so you have all of my details. But I do thank you for attending or watching later if you're watching later. It's just great to be back looking at the Discord channel there on the group. Large number of people, obviously a great place to hang out and a great user group there. It's fantastic. And thank you very much for inviting me and for attending the session. Thank you.
Thank you very much, Christopher. So that was efficient data handling techniques in Python for Oracle database. We have a few questions coming up.
Mm-hmm.
First from Neil Miller. Which tools do you recommend for measuring performance when tuning?
Well, Oracle has big and small tuning features. The one that I like is the overall one, which is something called Automatic Workload Repository, AWR. I believe it is an extra option to the database, but it is something which you can run your whole application against, and it'll give you, so you can take snapshots of what's happened in the database, and obviously you can compare before and after snapshots. Particularly if something is going nasty wrong, if you get some sort of load spike, then you can kind of see whether you've got an average, non-average behavior. But that will show you all sorts of things like numbers of connections per second, so you can see your connection rate to see whether you're over connecting and not efficiently using perhaps a connection pool. They'll show you, commits and rollbacks, so you see whether you're not efficiently using the or maybe over committing because you're committing every single statement, and maybe you should be committing by transaction. It'll show you things like parse counts so that you can see if you're efficiently using bind statements, so whether each statement has to be reparsed because you've not used bind variables and you've stuck the data as part of that statement, so it has to be reparsed. So you can see the parse counts. So from a developer point of view, I kind of like that. From a Python developer point of view, from SQL developer point of view, yes, there are SQL developer tools and there's auto trace and things like that in SQL Plus for looking at the SQL optimizer for the SQL statements. But I think AWR is a great place, and a lot of that data is available within the $V views. The example I showed with the round trips was an example where I could just access the same kind of data that AWR would capture just by doing a query against the what we call the data dictionary, and you can do all of that manually.
Thank you very much. Also a message from Ivan Blazik. Thank you very much, and Simon Cross as well. That was very informative.
Thank you
great,
for attending. Specialist topic, but it's just great to be out there and talking to people and hearing what you want.
And if we hide this one, there's your contact details for anyone who wants to get involved or in touch with you, ChristopherJones@oracle.com. Next up, we're listening to Developing Feasible Scenarios for Bioenergy Production in South Africa with Python by Hayden Wilson. Promises to be very interesting indeed. Thanks. And that ends this broadcast here.